All right, hi everyone. How are you all doing? Today I will be attempting a Codeforces round, and this is a Division 3 round. And apart from that, I haven't been really active on Codeforces for quite some while now. I mean, if I just show you my profile here, it is taking some time to load. But yeah, if you look at it, I mean, I have just solved 4 problems in the last 1 month, which is pretty bad, I would say. And yeah, I mean, the reason here was I had a hell lot of work to do with respect to the colleges, with respect to the courses at my college. And yeah, I mean, I am planning to be a little more active now on this channel. So yeah, let's see how this round goes. And yeah, like apart from that, I had opted for a course at my college which was requiring me to put in like around 10 to 15 hours a day, which was just insane. So I would be late dropping that course, and I am assuming that things would get a little easier, and I would be, getting some time to post videos here on YouTube. So yeah, hoping to be a little more active on this channel now. And I would be doing a post-contest discussion for this round after I'm done with this round, so you guys can check that out as well. And let me just see if everything's fine. Yeah, looks like cool. Also, this I think would be my first contest screencast from Hostel. Yeah, I mean all of my contest screencasts have been from home. I think yeah, this is the first one wherein I would be recording from Hostel. And let's just see if Sublime is fine. Okay, took a lot of time, but seems like this is fine. And yeah, let's go. Okay, Casimir has a string S which consists of capital Latin letters. Each turn he can choose to do one of the two following actions. He can either erase exactly one letter A and exactly one letter B from arbitrary places of the string, or he can erase exactly one letter B and exactly one letter C from arbitrary places in the string. Okay, therefore each turn the length of the string is decreased by exactly 2. All turns are independent, so for each turn Casimir can choose any of two possible actions. Okay, determine whether there is a sequence of actions leading to an empty string. Okay, so if we want an empty string, obviously all the characters should be ABC first of all, and the string consists only of capital letters. Okay, this is fine. Apart from that, if I'm using X A's and Y B's, then X A's and Y C's, then B has to occur for X plus Y times, right? So this is easy. I think this can be done. Okay. Yeah. Okay, so if S at I equals to an A, then I increase A plus plus. Else if S at I equals to a B, then I do B plus plus. Else I do C plus plus. So C out. A plus B A plus C equals to a B, right? In that case, I just print yes. Otherwise, I print no. Okay, and I also need to declare these variables. Okay, let's see if this is fine. Okay, no, yes, no, no, yes, yes. So this seems fine. Let's submit this quickly. Yeah, I think I've chosen the wrong file. It was c.cpp. Yeah. Cool. So this has got accepted. Let's move to problem B. Shifting sort. The new generation external memory contains an array of integers. Okay. This type of memory does not support changing the values of an arbitrary element. Instead, it allows you to cut out any segment of the given array, cyclically shift it by any offset, and insert it back into the same place. Technically, each cyclic shift consists of two consecutive actions. You may select arbitrary indices L and R as the boundaries of the segment. Then you replace ALR with its cyclic shift to the left, okay, by an arbitrary offset D. Cool. The concept of a cyclic shift can also be explained by following relations. The sequence is a cyclic shift of this. Fine. Sort the given array using no more than n cyclic shifts of any of its segments. Note that you don't need to minimize the number of cyclic shifts. Any method that requires n or less cyclic shifts will be accepted. Okay, fine. So essentially what I can do is I can look for the minimum element. Wherever it is, I can just bring it to the first place. I think that should be fine. Yeah. So this will be my answer vector, wherein I will be storing all these operations that I'm doing. So after this, what I do is I look for the minimum element. Right. For int j equals to I, j is less than n, j plus plus. And I want to find the minimum element, so int minimum equals to ARR at I. Yeah. And here what I do is I look for the minimum. So if, in fact, I also need to store the indices, right? So why not store it in the form of a pair? This is the minimum and this is the index. So initially it is ARR of I, comma I. Right. After this, what I do is I try to update it. P comma ARR at j comma j. Right. And can we have d equals to 0? Okay, d cannot be equals to 0. So if p dot first equals to ARR at I, then we don't need to do anything here because it is already at the minimum place. Otherwise, shift. I'll pass the ARR and I'll pass the value p, and I'll also insert this in my answer vector. So the indices are I comma, it should be I plus 1 comma p dot f plus, let's keep this also ff. In fact, this should be p dot ss plus p dot ss plus 1. And what is the offset? Offset is p dot ss minus I. Yeah, I think this should be fine. Right. Now I also need to shift it, right? So I can make a vector here. And let's define it. And I need the pair here. Okay. So this pair tells me that what is the minimum, and the index I tells, okay, I also have to pass an I here because I is the place where we will be shifting it, right? Cool. So I can maintain a vector here. Temp, and the size would be what? The size would be p dot ss minus I. Cool. Now what I do is I have a shift int d equals to p dot ss minus I. Cool. So I can do this. k is less than p dot ss. So this has to be a shift here. And instead what I can do is I can maintain a vector only because it would be easier to debug then. Right. So D is the shift that I'm doing. And what I do is I do this temp at k minus I. I'm shifting it towards the left. Okay. So D is the shift and I need to shift it. K minus I is fine. Minus I plus 1 it should be, because that would be the length. And how much do I need to shift? In fact, I'm shifting the whole suffix, right? I don't need this p dot ss. Okay. So I don't need this. Let's remove this for a while. Now I plus 1 is the index, that is fine. P dot ss is also the index, that is fine. But our shift is what? Our shift is this much. Cool. So here I'll be passing it this, right? I comma p dot ss minus I. Okay. Now the size would be minus I. This would be the size, right? I need to shift it cyclically towards the left. Cool. So start index equals to I. Okay. I is less than I plus plus. And I do temp at let's maintain as the whole size only. Cool. Now I do temp at I minus D. This whole part is getting shifted. Remaining equals to okay, this seems fine. I minus D modulo remaining. Cool. And after that I just update these values. Okay, ARR at k equals to temp at k. Right, let's see this if this is fine or not. And let me just debug this vector ARR every time. Answer at, okay, this should have been I. p equals to minimum of this. Okay. So I've made quite a lot of errors here. Oh, cool. Okay. So I have 2, 1 and it becomes 1, 2 after what? After 1, 2 and 1. Fine. For this one, I just do what? 1, 1, 0. How is it coming out to be 1, 1, 0? Okay. Let's try out this for this case only. 2, 1, 0. So initially we have this, and after that we're cyclically shifting this part. So this is like 2, 3 and 1. Fine. Start equals to this, remaining equals to this. I minus d. Oh, this had to be plus I, right? Plus start. So now temp was this 0 to 1. 0, 0, 0. Okay. After that, we want this 2 to go where? In fact, this should have been I minus start. Okay. What about this one? Okay, so we have 1, 3. 1, 3, 2, 4 is fine. Cool. And after that, we have 1, 3, 2, 4. So we want 2, 4, 3, which is fine again. And we have this. Then we have this. So this seems fine now. Fine now. Let's try to sum this. Okay. Cool. Let's submit this. And I just hope I've understood the problem correctly because it has taken up a lot of time. Wrong answer on test 1. Okay. Let's see. A1 equals to 4. Test 3. Okay. 2, 4, 1, 3. This is wrong. Let's see. So we have 2, 4, 1, 3. 1 has to be shifted here. So it has to be shifted by 2. Oh, this had to be different, right? I plus 1 and this had to be n minus 1. N in fact. Because we're shifting the whole suffix, right? Okay. So this had to be 1 to 4. Now they should be fine. So let's move to problem C. This one took up a hell lot of time, but yeah, there was some implementation involved. And looks like E is being solved by a lot of people. Let's see. I think I can try out E instead, E1. Yeah, let's try out E1 for now. Do not have much in common. You should probably think of them as two separate problems. Okay, a permutation P of size n is given. A permutation of size n is okay, fine. Let us consider an empty DQ. A DQ is a data structure. Okay, that is fine. Fine. The elements of the permutation are sequentially added to the initially empty DQ, starting with P1 and finishing with Pn. Before adding each element to the DQ, you may choose whether to add it to the beginning or to the end. Okay, fine. For example, if we consider the permutation this, yeah, fine. Find the lexicographically smallest possible sequence of elements in the DQ after the entire permutation has been processed. All right, so the very first observation here should be that one has to come at the starting. And how would we do that? We would be inserting it to the beginning. Whenever we see one, we would be inserting it to the beginning. Right. And what about the other elements? I mean, obviously, if you're inserting X anywhere, if X is less than the element that is present at the beginning, you insert that element at the beginning, otherwise you insert it at the end. I think this should be fine. So let us also make a DQ here. Okay, I'm not sure how it is done. Okay, so if sz at d equals to 0 or okay, let's just see how are these elements taken care of. DQ. So I'm not sure about the syntax here, that is why I'm referring to this. Push back, push front, okay, fine. And how do you check elements which are present there? Dot front. Okay, fine. Is greater than A. Then you do d dot push front A. Else you do d dot push back A. Now I do this. While sz at d is greater than 0, I do cout d dot pop front. Okay, let's see. One three 1324 123 132 12 and 12. Let's submit this is fine. Cool. Let's look at E2, I guess. Okay, turns out E2 doesn't have a lot of summations. Let's try out D. D has a lot more summations than the other problems. So let's try out D. Okay, but looks like Yeah, I mean, this should be solvable. I don't see a lot of red coders here who solved this, so this should be solvable. And I mean, the reason that I'm saying that a lot of red coders haven't solved it right now is because I mean, just see, because many a times what happens is people that are really pro, they start from the very end, or they start from problems that are really tough. So yeah, that is something that you should look out for in Division 3 contests particularly. An important meeting is to be held and there are exactly n people invited at any moment. Any two people can step back and talk in private. The same two people can talk several times per meeting, okay? Each person has limited sociability. Sociability of the ith person is a non-negative AI. This means that after exactly AI talks, this person leaves the meeting, okay? Yeah, fine. The person is considered most productive if the maximum possible number of talks took place during it. A meeting is considered most productive, okay? You're given an array A of sociability. A determines which people should talk to each other so that the total number of talks is as large as possible. Cool. Okay, now the thing here is that what I can do, I can pick up the maximum element and have a talk with every other element. I mean, I can pick up the person that has the maximum value of AI and talk to every other person, and I can do that so many times such that I mean AI doesn't become zero. And why would that greedy solution work? The question is this. For example, if I have, let's just open OneNote here, or in fact, I just have to write, right? So let's keep it on Sublime itself. So what I'm planning to do is sort the array, then pick the maximum and have a talk with all starting from end. Now, what this ensures is that the whole array remains sorted at any point of time. Does this is this getting ensured? I don't think it is getting ensured because there might be a situation where you have 2 comma 2 comma 2, and here you have, let's say, or let's say another 2, and you have a 3. So after I do this, my whole array would become something like it would become something like 2 comma 1 comma 1 comma 0. So instead of storing it in the form of an array, I can possibly store it in a multi-set. Yeah. But why would I not want to do something like this? Why would I not want to take it in this way? If I have 2 comma 2 comma 3, remove, I can just try to remove 2 elements from the end itself. So in this case, what would happen is this. You would have 2 comma 0 comma 1. And then after that, I can do this whole thing again, I guess. Yeah, but why would this not work, or why would the other thing work here? That is the question. In fact, if you look at this, the answer it's ultimately would become 3 here. Now the question is, how should I distribute? If I am taking the person with the maximum AI, how should I distribute this AI amongst all the other elements? Should I just pick up the second maximum and remove as much as I can? Or what should I do exactly here? So if I try to do something like this, I have 2 comma 2 comma 3, and I remove this 3 from all the other elements. For example, I can do this. I have 1 comma 1 comma 1. This would become, and then I can have 1 comma 0 comma 1. So I mean this also works here, but what would not work? Let's look at some of the sample test cases here. Maybe we can get a case where this does not work. So for example, if we have this, let's take up 1 2 3 4. Yeah, this can be a fine example. 1 comma 2 comma 3 comma 4. So if I take this approach of doing what I've written above, I would be doing something like this. I would be removing 1 from every other element, and this would become something like this. 2 comma 1, and after that I remove 1 from every other element, which would make it something like this: 1 comma 1 comma 0. So the answer here should be 5, and it is 5 actually. But what about this one, 1 2 3? I think this can be done again. Cool. So, and what are these values here? Are these values up till 10 to the power 9? These values are up to 10 to the power 5. Okay. So why shouldn't I just pick up the last maximums? For example, after picking the two maximums, my array would be something like this: 0 comma 1. So this works again, right? What if I had something like this? This would work again. I think I can just pick up the last two maximum elements, remove as much as I can, and then insert these elements back into the multiset. But is that helpful? Or is there a case where this does not work? If there are two elements, this is fine. If there are three elements, keeping in the sorted way, something like 1 comma 1 comma 4 here. So I would be having something like this: 1 comma 0 comma 2, and then this becomes 0 comma 0 comma 1. So this gives me the answer as 3, and 3 is the actual answer here. But what if I had something like 2 comma 3 comma 4? So this would become 2, 0 and 1, and after that it would become, it would become 1 0 and 0. So the answer here would be what? The answer here would be 4. Yeah, the answer here is 4. But can I have the answer as 5? Well, I cannot have 5. Why? Because the number of elements itself are 9 here. So if you look at the maximum element, and the maximum element is less than equal to half of the half of the total sum, then my answer is the final total sum. Yeah, that is possible. But what if it is greater, something like 6 here? So we would have 0 comma 3, and then I would have, oh right, I think the approach of just picking up the last two maximums should work. I don't see any case where this should not work, although I haven't proved it officially. But yeah, this should be fine. Let's make a multiset. And what are they saying here? The maximum number of talks possible in a meeting. Okay. So since all these values are up till 2 into 10 to the power 5, oh, the sum of AI is also up till 2 into 10 to the power 5, so this should be fine. Let's make a multiset here. So I would be having a comma I plus 1, right? So while s set of n is greater than 1, then I do pair equals to m dot begin. In fact, this should be m dot end. Or I can store the minus here, the negative values, and just pick up the first value. Okay, cool. M dot begin, and this should be a star here. Q, right? So what I do is I just print this, right? Okay, so I do answer dot pb p dot q dot ss. Now if p dot ff is greater than 0, then I do m dot insert p. If q dot ff is greater than 0, then I do m dot insert q. Okay, let's see. One, 2, comma 1. So I have the answer 1, then I have the answer. Oh, so just a minute. Let's just debug m at every point. Yeah. And let's have this as 1. So m becomes empty here. But what about here? Oh, this should have been plus 1. And this should have been less than 0. Cool. And do I also have to print it in a certain way? Okay, so the order does not matter here, which is fine. So I have 2, 3, 5. Then I have 2. Then I have 5. Okay. Also, if a is equals to 0, then I don't need to do that, right? Yeah, this is important. Okay, so this is fine. Let's submit this. Okay, great. Right, so I think now we can move to problem C. This has a lot of summations now. Okay, taking up a lot of time. Cool. Yeah, let's look at problem C and then I think we can move to problem E2. Yeah, this should be fine. Let's move to C for now. Casimir has a rectangular piece of paper with a checkered field, okay, of size n into m. Initially, all the cells of the field are white. Let us denote the cell with coordinate I vertically and j horizontally by ij. The upper left cell will be referred to as 1, 1, and the lower right cell will be referred to as nm. Okay. Draw sticks of different size on the field. A tick of size d with its center in cell ij is drawn as follows. First, the center ij is painted black. Oh, all right. This is all the cells with coordinates. Um, right. Between 0 and D are painted. In particular, a tick consists of 2D plus 1 black cells. Fine. An already painted cell will remain black if painted again. Below, you can find an example of the following of the 4 cross n box. With two ticks of size 2 and 3, you're given a description of a checkered field of. Casimir claims that this field came about after he drew some ticks on it. The ticks could be of different sizes, but the size of each tick is at least k. That is, d is greater than or equal to k for all the ticks. Determine whether this field can indeed be obtained by drawing some ticks of size. Okay, I'm not sure what this refers to here. So basically, they have already given us the whole grid. And after that, fine. You're given a description of the checkered field of size n into m. Casimir claims that this field came about after he drew possibly 0 ticks on it. The ticks could be of different sizes, but the size of each tick has to be at least k. Fine. Then determine whether this field can indeed be obtained by drawing some possible ticks. Oh, okay. All of them have to be size greater than or equal to k. That is a constraint here, and these are a size 2 and 3. Fine. Now the thing here is that there shouldn't be any black cell that is left out. I think that is one requirement here. Whether this field can indeed be obtained by drawing some ticks of size d is greater than or equal to k or not. Okay. Okay, so what I can do here is that for every element, I can consider it to be the center. And if I consider it to be the center, I first of all have to move upwards. And I only have to move upwards, right? Yeah, I only have to move upwards. So I start moving upwards. And as soon as I see that my distance overall has become greater than or equal to k, that means I can mark all these cells. And I continue to mark them until I keep finding, corresponding black cells above. So I can do this for every particular cell. And after I'm done with this, I just need to check if I have covered all the black cells or not. Yeah, right. So yeah, this seems like a fine thing. I can try it for every given cell. I can try iterating upwards. So first of all, I have int n comma m comma k. And then I have two vectors. So I have this given vector, and I have this obtained vector. And initially all of them have to be dot, right? Cool. So this is what I do. Given at I comma j. Fine. Now I just have to iterate. First of all, if given at I comma j is not a black cell, then I don't need to do anything here. Right. And otherwise I just iterate. So I can make an iterate function, and I can store in a pair of vectors, a vector of pairs, which will tell me which all cells do I have to mark. Right, and I can pass an I comma j comma given comma mark and comma k. Right. Now if, in fact, let's just remove this k part. If sz of mark is greater than equal to 2 into k plus 1, then I just mark all these cells. Auto L, let's keep it like this. Mark. Obtained at L dot ff L dot ss equals to a star. And at the end I just compare. So I have to make this iterate function. Vector pair of, okay, this is a different vector. And I have vector of mark. Okay. So while I is greater than 0 and then j is greater than 0 and then, okay, so I have 2 pointers right here. Yeah, let's keep it like this. While down is greater than 0, left is greater than 0, greater than equal to 0 in fact, and then right is less than given at sz of this, and given at left, in fact this should be down star and given at down comma right equals to a star. Then we do mark dot pp. In fact, let's keep it like 2k plus 2, because we will be inserting one element again, right? So I have down comma and I have mark. Right, let's see. Okay, so I have no yes, 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 and no, 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 no. Fine, let's submit this. Cool. Now I think we can move for E2, I guess. Yeah, E2 should be fine now. Yeah, let's try out E2. In fact, do not have much in common. Yeah, that is fine. A DQ is a data structure. This is also fine. Sequentially added to the queue, empty queue, starting with fine. Find the minimal possible number of inversions in the DQ after the whole array is processed. Minimal possible number of inversions. Okay. So what this means is that bigger elements should be towards the right. I think that is what you want. And do we also need to find the number of inversions? Fine. That wouldn't be a very big task here. Okay. I think when we are talking about lexicographically smallest, we do mean the least number of inversions, I guess. And why wouldn't we mean that? A lexicographically smallest permutation would be the closest to a sorted permutation, I guess. Yeah. The more close you are to a sorted permutation, the better it is for you. So if I am no now the case is a little different. If I insert an element A, let's say here, and I want to insert B, where do I insert it? I know how many elements are bigger than this, how many elements are lesser than this. If I know that the number of elements that are lesser than this are more, then I insert it at the end. Oh yeah, this should be fine. This is fine. Let's take in the first part itself and do that. So we essentially want to minimize the number of inversions, right? So for every place, we just count how many elements are there which are lesser than this. So I have, this is fine. Now we want the number of elements lesser than A. And how do I get this count? Well, I can use a PBDS here for getting the number of elements that are less than this. Yeah, a PBDS should be fine. Cool. So at this point, we also insert a dot insert a comma I. Yeah, by this we are maintaining the order. I mean, we are maintaining similar elements in the PBDS. So I just find the index. Int index equals to a dot find by order. Or in fact, it was order of key, right? Order of key a comma. Now there might be similar elements again here, right? So if I do a minus 1 and I do infinity, this would tell me the number of elements that are lesser than this. And then I can do index 2 equals to a dot order of key, again a comma infinity. And so int same equals to the number of elements that are similar are index 2 minus index 1, and int smaller equals to index 1 plus 1 and int bigger equals to sz of a minus smaller minus same. Right, now if smaller is less than bigger, that means bigger elements are more, and I do here what I can do is I can just maintain as pbds and in fact I don't need this, right? I don't need this DQ now, or let's just keep it. It is not harming us in any way. So a dot insert, this is fine. Then I do answer plus equals to minimum of smaller comma bigger. Yeah, and at the end we just print this answer. -1. Okay, let's debug this now. Let's debug pbds a, then let's debug. So this is what we have. These are the number of elements that are smaller than this. So in fact, this is what we want. Smaller is this, right? Same is this. Yeah, right. Same as this, and then so I have 2 here now. Okay, now I am getting so I'm getting 2 0 0. The third test case is coming out to be wrong. So let's debug that. Yeah. Now I have 3 0. So if I insert 1 here, okay. What about for the case of 2? Index 1 is coming out to be 0. But index 1 should have been 1 here. PBDS is 1130. A minus 1. So this should have been index 1 should have been 1, I guess. Oh, just a minute, just a minute. This should have been pair LL. Oh, right. This should have been LL. Because it is becoming negative, there is an overflow here. Yeah. I think now this should be fine. So I have 201012. Cool, let's submit this. Okay, fine. So now we can look at problem F. You're given an array A of zeros and ones only. Note that in this problem, unlike the others, the array indexes are numbered from 0, not from 1. Okay. In one step, the array A is replaced by another array of length n according to the following rules. First, a new array A, D, is defined as a cyclic shift of the array A to the right by D cells. The elements of this array can be defined as AD, A plus n minus D. Okay, I mean it is like A plus D. It should be A plus D, right? If we are cyclically shifting it by D cells, okay, I mean this is not required. Um, Fine. It means that the whole array A is represented as this. Okay, fine. A of 0 equals to this. Fine. Then each element of the array is replaced by AI and AID. Oh, right. Fine. For example, the process ends when the array stops changing. For a given array, determine whether it will consist of only zeros at the end of the process. If yes, also find the number of steps the process will take. Okay, fine. So we are cyclically shifting this whole array by D cells. So we'll be taking A of 0 and A of n minus D. N minus D plus 1. Fine. Okay, let's look at this problem on one note. Okay, this is the wrong one note. I wanted to open the other one. Okay, so the thing here is that if we look at this whole array, if let's say this element is a 0, so after one step, what would happen is that it would move d steps forward, or in fact, it would move n minus d steps forward. I mean, I'm not sure about this. I think we would be moving d steps forward, not n minus d. 0, 1, 1, and this would become something like this. Oh, right. So we would be moving d steps forward, and we would be making this one a 0. Similarly, we move d steps forward, we make this one a 0. Then we go here, we make this one a 0. And we come back to this place. Now, the thing is that after so many steps, how many steps would these be? How many steps would we require? That is the question. And would I ever return back to my same place? So if I do d into n I plus d into n steps and take a modulo of n, then obviously this would get back to its same place. So after n steps, definitely we are going back. But can we go back in lesser steps? For example, if I am here, for example, let's consider this one. I have 0, 1, 0, 1. So this would go here and then this would come back here. So in just 2 steps, this is happening. And k equals to 2 here and n equals to 2. So all I want is that k times d. Let's say, in fact, let's keep it like this. This is d. I want d into k to be a multiple of n. This is what I want. And I want the smallest k here. So the smallest k would be n divided by GCD of n comma d. GCD of n comma d. Yeah, these are the number of steps that would be required. Right. So after these many steps, after n by GCD of n comma d steps, I would be returning back to my same place. And now the great part here is that this part, like when I'm hopping, this is fixed, right? Coming back here and then going back here. This is fixed, this path is fixed. So if in this whole path, if there is just one 0, just a single 0, then this whole path can be converted to zeros. And after performing these many steps, I don't need to do anything. That is the thing here. And why would I not do anything after this? I mean, that's just because the whole path would be getting repeated now. So I wouldn't be doing anything after n by GCD of n by d steps. So these are the maximum steps that we're going to do. And we just have to see if all of the elements become 0 or not. And now all these paths that I'm talking about, if I start at index I, these paths are basically, these are fixed, right? So, yeah, this is fixed. So for every single path, I can find out how many steps are required to convert all of them to 0. Right. And what would be the number of steps required for any path? For example, if I have a 1 here, I would want the closest 0. the position of the last 0, which is closest to this one. This is what I want, for this 1 to be converted to a 0. Right, and now let's say if I have a 1 here and a 0 here, so what would happen here? This would become 0, this 1 would become 0, and then we would be going back here. So in fact, for this one, if I have a 0 here, this is fine. If I have a 1 here, then the answer is basically just the answer for this and the number of steps required. Yeah, fine. For example, if I have a 1 here, if all of them are 1, then nothing can be done. If just one of them is a 0, then I can start converting every element to a 0. And as soon as I encounter 0, I can just make my steps to be 0. Yeah, I mean, this should be fine. So let's just break this whole thing into parts here. So what do I have? I have these values. Fine. Okay. Now I have vector of paths. Cool. And I can have a set here. So if not used, dot count I, then what do? I just make another vector here, path.pbi, j plus equals to d type. And what do? I just do this, path.pbj, used.insert j. Fine. And now I can just debug these paths here. Fine. Okay, I also need this, right? Let's keep it like this only. Paths.pb, okay. Okay, so for this one I have 0 and 1. But this could have easily been 0 and 1, right? Used.insert j. Let's look at it like this. Plus d. So why am I not getting 1 here? I should be getting a 1. J equals to I, which is 0. Then j is less than n. J plus equals to D. So why exactly is this not working? N comma D I have. Oh, okay. I think there is some issue here. D is coming. Oh, okay, okay, okay. I haven't taken the input. Cool. Now what I have to do is I have to iterate through all these paths. So what I can do is I can just maintain a path. I can just copy this path again, right? Uh, I just have to double this, right? Okay. So I just have to find the number of, okay, fine. Fine. Now here what I have to do is I just have to look for 1 0, and I think we can start anywhere, I guess. Yeah. 2 into S Z. I mean, we are just iterating once again, right? 2 into S Z of S Z of I, J plus plus. Int index equals to J modulo S Z at I. Now, okay. Now if I at index equals to a 0, then I just do prev answer equals to 0. Else prev answer plus equals to 1, because these are the number of steps that we require more, right? And we do answer equals to okay. If pref answer is not equal to 1 6, then we do answer here equals to max of. Right, because these are the steps that will be required here, and here we do. Okay, all ones is not defined. So let's just define it here. Why just make a function here? Or in fact, let's define it above only. one step is required here. -1, -1, and -1. Okay. So let's debug the paths here. I think this is the case where it is not working. So let's try out this one. Oh, in fact, this had to be, just a minute, we have 0 and 2. So these would be the steps that would be required. Zero to 4, and I have 1, 3, 5. Okay. Plus equals j equals to modulo. Or in fact, let's keep it like this now. Okay, fine. Now we need to insert, in fact, we need to insert ARR of j here. Okay, 1, 1. And I have 1, 0, 0, 1. Okay. But let's try this case again. Okay, let's see now. Yeah, this seems to be fine. Let's submit this. Okay, I'm not sure why it is taking up so much time. Maybe I'm not passing I by reference here. Maybe that's why. Or maybe it has a lot of test cases. So let's look at problem G. And I hope this is not a graph problem because from the name it seems like okay. So this has worked. Let's see. Okay, let's look at G then. You're given n lengths of segments that need to be placed on an infinite axis with coordinates. The first segment is placed on the axis so that one of its endpoints lies at the point with coordinate 0. Let's call the endpoint the start of the first segment, and let's call its end as the endpoint that is not the start. Okay. The start of each following segment must coincide with the end of the previous one. Thus, if length of the next segment is d and the endpoint of the previous one is x, is placed. Oh, okay, okay. Is placed either on x minus d comma x or x comma x plus d. Okay. If the okay, the start of each following segment must coincide with the end of the previous one. Hmm. Fine. The total coverage of the axis by these segments is defined as the overall union, which is basically the set of points covered by at least one of the segments. It is easy to show that the coverage will also be a segment of the axis. Fine. Determine the minimal possible length. Okay, okay, okay. Okay, can we keep the first segment towards the right? I mean, it doesn't really matter. We can keep it towards the left or the right. It doesn't really matter. All we're concerned about is the final length. Fine. And how much time did my last submission take? 795. And the limit is 2 seconds. This should be fine. So we want the minimal coverage, right? Now all of these values are up till 1000. So why would I ever go beyond 2000 in the left side and beyond 2000 in the right side? Why would I ever go in that direction? I wouldn't, right? Yeah. So if I'm standing on x coordinate and I am at index n, I mean index I, then this can be done using dp. Okay. But we also need to keep track of the other one. Like if we are standing at the left x coordinate, we also need to consider the rightmost coordinate. So the thing here is that for every segment that you're getting, you can either put it towards the left or towards the right. Okay. Now, okay, what if I define the longest that I want to go towards the left? Let's say I allow you to go towards the left up to such a coordinate, something like 2000. Then what this means is that for all the other, uh, okay, but this also has a limitation. Okay. Okay, yeah, I think I can iterate on this fact that if I keep my left most pointer towards so much, or let me explain it like this here. So what I'm trying to say here is that this is my axis, right? If I say that I can go up to the left only till so much. Now, what would you do here? Like you would come here, and as soon as you see that you cannot go, I mean, you cannot put the segment again here, you would put it this side, right? And you would keep doing this. Yeah, I think this is fine. But this would be like 10 to the power 7. This should be fine. Yeah. So let's say that I want to go up till 2000. And all these lengths are, yeah, maybe I just don't want to go towards the side. That can also be a thing here. Would I ever go beyond 2000? I don't think we should be going beyond 2000. Right. Now, so int current equals to 0. Int max left equals to 0. Int max right equals to 0. Okay. Now, so if ARR at j plus current is less than equal to I, we don't need this max right here because max right is I. If this is the case, what do? I just do this current plus equals to ARR at j. Else I do minus equals to ARR at j, and I do max left equals to minimum of max left comma current. So our answer here would be answer equals to minimum of answer comma I minus max left plus 1. Okay, this had to be brought here. So I'm getting 4, 4, 10, 10, 8, 10. In the third sample, okay, let's look at the first example itself. So I'm saying that we can go up till 1. Let's say I tell you that I can go up till 1. Then let's start with 20 here. So I'm going for minus 4 and 0. If ARR at j plus current plus equals to this, else current minus equals to this. Fine. Okay. What about this one? This is covering 4. This is also covering 4. How exactly are they covering 3 here? So I have 0. Then I go till 1. Then I have 1, 0. No, no. For example, if we talk about the fourth example, okay, let's look at this one. So I'm getting the answer as 10, and the answer here is 9. So I have 0 to 6, then I go from 6 to 4 here, okay. Then I go from 4 to 7, then I go to 0, 6, 4, 6, minus 2, 7. So the total length, oh, achha, the total length had to be this. Three, 3, 9, 7, and 9. Okay, so in the last one I'm getting 9, which is not correct. So I have minus 11 and 0. How exactly are they getting 8 here? If ARR at J plus current is less than equal to I, then I do this. Okay. So let's maybe pick up a smaller case, or in fact, let's keep it this only. So when I have 0, then I'm going up till minus 11. Okay. Um, let's debug current here. So I have minus 8, then I go to minus 2, then I go to minus 7. Yeah, fine. Then I go to minus 6, then I go to minus 2, 4. Okay. This is fine. What about for the case of I equals to 1? I go till minus 8, which is fine. I go to minus 2, then I go to minus 7, and then I go to minus 6, minus 4, minus 2, 1, and minus 5. Okay. I think I have to go 8 towards the right. Only then will it help. So I have 8, then I go for 2, then I go 7 again, 8 again, 6, 8, 5, and minus 1. Can we do something different here? That is the question. 8, 2 is fine. 8, 2. Then 7 is fine. Okay. What about for the case of this 7? I go for minus 8. No, this doesn't work out. How are they getting 8 as the answer? Eight, 2, 7, 8, 6, 8. Can we do something different? Like if I just do minus only here, I'm at 8, I do minus 2. Then again, if I do minus 2, and then I do plus 3. This would be 7, right? Yeah, right. So why should I always go towards the left? I mean, why should I always go towards the right when I have the opportunity to go there? Instead, what I can do is this. If ARR at J plus current is less than equal to I, and ARR at J minus current is less than. Okay. If it is already less, then maybe we can go towards the left if I have the place to go there. Yeah, I mean, if I have the place to go there, why not go there? Okay, now I'm getting a totally different answer, 216618. So let's look at the first case itself. So I have current equals to -1. Oh, this should have been current minus. I'm again getting 9 now. 3, 3, 10. Okay. Fourth and third it is given. Okay, fine. So why am I getting -6 here? If current minus ARR at J is greater than equal to max left. Okay, this is fine. So I want to go for 0 to 6, right? When I equals to 6. Yeah, so I go for 6, then I go for 4. 6, then 4, then 1. Instead, if I would have gone, so it is 0, 6, 4. Okay, what about this one? 6, 4, 1. And then I need to go 9, right? No, no, this doesn't work out. I don't know, I have a very strong feeling that this is about DP, but I'm not getting a good state right now. I just have a very strong feeling this is DP. The constraints are small, the value of AI is very small. Okay, how about binary search? If I am at, if I say that the limit towards the right is this much, then I just have to binary search, right? That if I'm defining my right limit, can I push my right, I mean, if I'm defining my left limit, can I push my left limit towards myself? But how would I check if that works or not? Again, I will have two choices, right? At every point, I can go here or here. And I don't know where should I go. That is the condition. Okay, how about doing it like this? That if I have a suffix, if I reduce the problem to just saying that how much would this suffix take? How much would a spread be like? Right? Okay. How should I decide that whether I should go left or right? How should I optimally decide that? That is a question here. One of the things is fine that if I have some space remaining towards the right, I should go there. But at some points, I will have to go towards the left. If I continue to go towards the right, I will have to go towards the left at some points. Where should I move? Should I move to the place where it is closer to the? Oh, okay. I think I should move towards the place where I move closer to the end point. Yeah, I think this is what I need to do. So if current minus ARR at chase greater than equal to max left. Um, okay. Current I minus current minus RRHA. Now if diff1 is less than diff2, then I should do this. Else I should just do this. Okay, let's see. I am again getting 9 here. I don't know, I don't think I will be able to do it by the end of the contest. I'm just trying out a bunch of random stuff here. This is just pure greedy. So, for the case where I equals to 8, let's say, I do 8, 2, 7, 8, 6, 8, 5, and -1. Okay. What about 7? Okay, 7 doesn't really work, so that is fine. When I go for 8, then I go for 2, then I go for 7, and then I go for 8, 6. So if instead here I go for 4, and then I go for 7, right? That should be better. But how do I decide that? I am going to the closer side. To the side that is closer. I don't know, this is just insane. This has to be DP. I mean, I have a very strong feeling for this. Greedy shouldn't work here. I'm not able to think of any valid greedy approach that should work here. All of them have like cases where they fail. What if I say that I have fixed my left limit and the right limit? That you can only go in between this. This internal part has to be TP for sure. And this upper part, maybe if some binary search works here. When the pointer is between both the max and the max left limit and the max right limit, then we have to decide where we have to go. So for that, it is definitely DP. For I and J, I can definitely check this. That should be fine. Yeah. But fixing the maximum and the minimum limit, that is just way too complex. I don't know. I mean, I am not thinking about it further. I will have to look at the tutorial or some solution later on. So yeah, I think I'm going to end the recording now. There is no point in attempting it further. Okay, then I hope you all had a great time watching the screencast. I would be, covering the solutions to all these problems that I've done in the post-contest discussion. And yeah, I mean, if there is somebody who has done the G problem and I mean, I find him or her on my server, then yeah, I think we can invite them for covering this problem. But yeah, overall, that was it. I hope you all had a great time. Bye bye. See you all.